Okay, so here we have the next question that we have on the menu today, and it is asking us the drawing. Well, we don't have the drawing, so we're going to have to imagine based on this information. The drawing shows a laser beam shining on a plane mirror that is perpendicular to the floor. Let's actually draw this as we read this so we can kind of keep in mind what is going on. So it mentions that we have a mirror. Let's make this our mirror representation. And they mentioned that the mirror is perpendicular to the ground. Okay. We have a laser beam that is shining on it, and the laser beam is has an angle of incidence of 37.8 degrees. Okay, so essentially what that means is, let's say we have a red laser, like this, and like this. So it's saying that the angle of incidence, which is the angle that it makes with the normal, and with a mirror, they're going to be the same. Like the incoming and the outgoing have the same angle of incidence, and this angle they gave us, it is 37.8 degrees. Okay, cool. The beam emerges from a laser that is 1.1 meters away from the mirror. So this distance right here, 1.10 meters, and 1.8 meters above the floor. Okay, so now it doesn't say if the laser is pointed down or pointed up. I'm like, the question mentions that it originally came from a drawing, so a drawing would make that clear for us. But no such luck. We will need to make a guess and hope that it comes good. The final answer here that they have is 1.2 meters. So given that, we can assume, if the answer here, if we want to like be in line with that, since this is lower than the height, we can assume that the laser up here, the laser is like the top one. Okay. Laser, and this distance, that is 1.8 meters. Ignore that the diagram is not to scale. Okay. How far from the mirror does the base strike the floor? Okay, so this is what it's asking. Okay, so the laser has to be above it, otherwise the laser would hit the ceiling. Okay, so I guess the laser continues to follow this path. So at this point right there, it is asking us, how in the world, or what is this distance? So let's just call that D. That's our distance that we want to know. And yeah, this would be a full visualization of the question. Let's just make that smaller so we can see there. And yeah, okay, so this is a representation of the situation. So we're trying to find D, right? So using some quick geometry, we can make some conclusions. So this angle right here has to be theta as well, and this angle is also theta. The reason why is because, well, the normal of the mirror has to be parallel to the ground, because the mirror is perpendicular to the ground. So this line right here has to be perpendicular, and we know that a diagonal that goes through two parallel lines like this has to have the angle orientation like this. So like this angle right here always has to be the same as this angle. Same vice versa for these angles right here. Okay, so if we can find out what this angle is, we know that if we have the height of of the point where it hits the mirror. Let's call this h. We know that this makes a right triangle, right? I'm rightly sure this makes a right triangle. So given this is a right triangle, h and d, the relationship that they have with theta is tangent, right? So tan theta is equal to h opposite over adjacent. So it's h over d. Okay. Now we have two ingredients of this. Like if we were trying to solve, we're trying to solve for d, so that it's h over tan theta. We need to find an expression for h. We need to solve for h. And a very important key that we need to solve for h is that we need to find this distance right here. Let's call that x. Okay. So now that we have this x value, we should also, let's call this 1.1 meters here. Let's call that L. Wrote that in. Now that we have this x value, we have another right angle triangle here. And we can use the tangent because we know L, we know x, and we know the angle here, and we know that they are also related through theta. Tan theta. So tan theta is going to be equal to the opposite over adjacent. So that's x over L. And what do we know about x? Well, we know that x plus h equals 1.8 meters, right? That was given to us by the question. So x plus h equals 1.8 meters, which means that x has to be equal to 1.8 meters minus h. Fairly straightforward. So we could rewrite this as 1.8 over 1.8 minus h over L. And then we want to solve for h, or isolate, because we need the h there, isolate h. And to do that, we will have multiply both sides by L. So we have L tan theta equals 1.8 minus h. And to isolate h, we have h equals 1.8 minus L tan theta. Okay, so we have this h expression, and we have this. Combining these two situations together, and like this. So if we have d is equal to 1.8 minus L tan theta all over tan theta, this should give us the d value that we're looking for, which is how far from the mirror the laser is going to contact the ground. Okay, so we know that L is equal to 1.1 meters, and we know that theta is 37.8. So let's sub these in. So we'll have 1.8 minus 1.1 times tan 37.8 degrees, all divided by tan 37.8 degrees. Okay, so let's run this through the calculator and see what our result is. 1.8 minus 1.1 times tan 37.8. That whole thing divided by tan 37.8. And my result for this calculation is d is equal to 1.22 meters. And that seems moderately reasonable because as we can see from the diagram, we would expect it. I know not everything is to scale, but you know, it feels like a reasonable answer that is going to appear farther than the original length here. So yeah, d 1.22 meters seems reasonable. And that was all with the power of trigonometry, is how we were able to put all of these pieces together, and then everything looks good. So 1.22 meters, exactly what we got here, so that's awesome. Explanation is a little bit lacking though, so I'll leave a comment on that. Solution is good. A more visual representation of how, of where that calculation came from would be better, as is not clear right now. Okay, cool.